All right, CNT140, Chapter 9. We're down to some checklists for the design. So some of the last couple of things they mentioned here about with the process of design, there's some checklists they have for making sure that all the pieces get done. And some of these steps might not be needed in an install. Other installs, they might be needed. So it's critical to make sure you don't miss anything. So here they have a bunch of things of like, okay, what kind of communications need to be done when looking at your link, if you will? What kind of communication for the contractor would need to be done if you're subcontracting out? Requirements needed for the cable plant, completion of the cable plant install, who's doing what, and kind of like what gets done. And then a final checklist might have things about actual testing and so forth. What components need to be ordered, delivered for install, and then as we get towards the end, testing and so forth. There might even need to be special install equipment to be scheduled, whether it be the plows or the trenching tools, that sort of thing. And it might even need to be a contractor that you're hiring to do that. In some job sites, there might need to be security for the equipment that's being stored. So that would need to be planned for. So work plan should be developed, indicates what specialties are going to be needed and when. Again, I kind of mentioned some of those things just a second ago. I might have one cable pulling, another splicing, and maybe even another testing, or might be somebody in the same crew that's doing the splicing is also doing the testing as well. So there might need to be special installers for special parts of this, and that would need to be scheduled and arranged that they're there at the appropriate time. We're not sitting around waiting for them. Things will go wrong inevitably. So your personnel should be briefed on safety rules. Who's the supervisor? Who are you contacting? The supervisor need to have contact numbers for a lot of people for planning as well as communicating with. And some might actually require outside work. If you're working in some buildings, you might need to work after hours in the evenings, so you might need special arrangement to do that and be communicating with what's getting done when. When are we allowed to bring this part of the network, work on this part of this network? During the install, there needs to be a knowledgeable person on site. Again, that could be the project manager or their assistant. Having somebody available that's technical, has technical knowledge, is really helpful. That's what we said early on in the project manager should be somebody that has background in or skills in, because they can answer the question like, no, we don't need to do that yet. Let's do that later. Or no, this has to be done now before we seal it up. We don't want to have to take the time later. Projects may require sign-offs by certain people who are licensed, whether it be engineers or so forth. That has to be planned for. Sometimes it takes time to do that. Cable plants might work with cities or counties and might need permits and easements. Again, that needs to be planned for. Time needs to be planned for. Sometimes these meetings happen on a certain day of the month. You miss it, you got to wait a month. So some of this has to be planned or thought about ahead of time. You might need facilities for termination, whether you have that trailer or truck or not, or you might need to schedule that truck or trailer to be on site at certain times to do the terminations and testing. After you're installing, or maybe even during your installing, what's your test plan? After install, after splicing, things need to be tested, and sometimes it needs to be tested there before you seal it up and put it in splice cases and that sort of stuff. Testing it while it's all out is easier to repair. It takes less time to repair. So sometimes you're actually doing this as you go. Yeah, right here. Often confusion on what should be tested and how documentation is supposed to be done. So as you're doing this, what needs to be tested and what results need to be saved, so we can have that for part of documentation. So that should be upfront and upfront on the plan. It might actually require 3 tests over time. Testing the reel when it gets delivered, giant reel of fiber optic gets delivered to the site, a couple kilometers long. You might need to test it then and there to make sure there's no damage. Once you put it in, Each segment might need a loss test, and also verifying that every splice that's made is good. And then after you get so far, we might need a loss test across that link. So there might be a couple as you go. And again, those results are saved for documentation purposes. And they remind us of, hey, when you have a large spool of fiber optic delivered, you need to check it, visually check it, to make sure things are functioning or it looks like it's okay. And you might even do a visual fault locator test on it. Connector on each end, throw a visual fault locator across and make sure light comes out the other end. We said before about insertion loss. After installing, we need to do insertion loss test with our optical loss test set. This is like we used in the lab room. We'll make sure we specify out 0 decibel reference and then how much loss as we plug it into the cable plant. And again, this would need to be agreed up front. What test is needed? What factors need to be in place, or what factors are used for the test? OTDR testing is generally done on outside plant, not usually on inside plant, but OTDR testing is not acceptable for cable plant certification. You need your loss test on it, but the OTDR would help verify your splices and lengths and so forth. And then long outside plant might need special tests, as we mentioned before, spectral attenuation, chromatic dispersion, or your polarization testing. Test plan should be coordinated with the cable plant documentation. Again, what is needed, and then as you test, documenting those and saving those results. Yeah, here they remind us, that cables are often broken sometimes by digging around, so it might need to be re-terminated. Okay, so when a break or something occurs, there needs to be a plan of like how are we gonna restore this, how are we gonna fix this, and then having either trained personnel or somebody that is contracted to come and respond to and repair, finding it, knowing how to fix it, have the right parts, and then actually do it. Documentation, the most helpful thing you can have when starting to troubleshoot a fiber. Yes, we need to know what's there and what was normal to know, oh, this is now abnormal. This is approximately where the problem is. This is where we're going to start looking at it. Documentation during the install, mark every fiber, keep it labeled, keep records. When tested, add all the testing data. And there should be somebody in charge of keeping all that up to date. And that is going to help with your troubleshooting and restoring, if you will. You got to have proper test equipment to troubleshoot and restore cable plant. They remind you here, on a premise cable, you might just have a visual fault locator. It's enough to know, yep, it is broken. I'm going to need somebody to come in and re-terminate or repair or replace. Longer cables, OTDR might be helpful for testing that to know maybe where exactly the problem is. Once you find the problem, you have to repair it. You need to have the right tools, supplies, and trained personnel. Again, I said this a little bit ago. You might need to have contract with somebody that can come and do that. Your premise cabling network, a lot of times your IT personnel there are okay with copper, but they're not trained for fiber repair, so you might need to have somebody contracted that will come in and do fiber repair. Your staff might be trained into, okay, move over to this fiber here and we'll use this one, mark this one, that this is one needs to be tested and repaired. Yeah, every install, any excess cable, connector source, so forth should be set aside. Even extra patch cables set aside, so you have them to try to restore that run, hopefully as quickly as possible. Yeah, big problem in restoring damaged cables, pulling two of the cables close enough to allow splicing. That's where the service loop should be in place for that. What else should be installed in here? Terminations, mechanical splices, those kinds of things, documentation of what needs to be done, and have those available. Personnel need to be properly trained to do this. Again, your staff might be able to identify the problem. You might need somebody else to come in and actually do the repair on it. Managing fiber optic product can be the easiest part of the install if the design and planning have been done thoroughly and complete. Yes, good design, good documentation make the install go a lot easier. Again, someone be in charge. Everybody else needs to know who the boss is. That way, there is not 4 different people answering the same question and answering it differently. Everybody responsible for the project needs to have documentation, be updated on the install plan, know who contacts are, know who to contact for, and then also have the on-site supervisor that people know to come to. Your location of components, tools, etc. should be known, and you might actually have somebody on a larger job that is their job to maintain equipment, materials, and signing in, signing out, arranging rental equipment, that sort of thing. Outside plant, we might have local authorities that need to provide, that we need to communicate with. We might even need traffic management from your local police, if you will, or I might need to contract a traffic contractor that's going to do some traffic flow, the flagging and so forth, like the flagger force. You might need to contract with them for the job you're working on. If the job you're doing requires inspections, you might need to arrange and plan for that. Sometimes that's a county thing that you actually have to arrange for them to come out and check off things before you close it up, if you will. And your supervisory people need to be in charge of job site safety. And that might require daily meetings or progress checks, a quick check-in in the morning. Hey, don't forget this. Today we have this particular equipment on doing this, stay out of their way, look out for this, etc. And again, you might need overnight security personnel on some job sites as well. Any inspection or testing should not be left till the job is done. Again, some testing might go on as you install certain components and compiling that data. And as things go wrong, who do you need to contact? How do you need to plan? Who do you need to notify? And that's, again, where you have the job site manager is helpful. After the install, relevant personnel should meet, review to make sure everything got done, everything's documented correctly before you sign off and basically close out the job. So there's our chapter on design.